So this week in physics, we're going to be looking at the concepts that surround refraction. So last week we were dealing with mirrors. We were looking at reflection, slightly different. Now we're going to be looking at refraction, which is still dealing with light. So let's talk a little bit about what refraction is. Light travels in a straight line. We know that from last week. But it does bend as it passes from one medium to another medium, such as from air to water. The bending of light as it passes from one medium to another is called refraction. So refraction still involves light. It involves light traveling in a straight line, just like when we were looking at reflection. But with reflection, what would happen is light would hit the surface and it would bounce back. Now what's happening with refraction is light is traveling from one medium to another medium. And as it travels through that medium, that light, rather than being bouncing back, is actually going to bend. It's either going to bend away from the middle or towards the middle. And that's what we're going to be studying in this section of physics. So let's start by looking at some of the optical illusions that refraction can cause. You might have noticed before you have your spoon in water here. So if you look at a spoon in water from the side, you can actually see that the spoon appears to be bent. You have part of the spoon down here and part of the spoon down here. That's because light is traveling through two different mediums. The light is traveling through the air up here, and the light is traveling through the water down here. Traveling through the air, it's moving faster, so it reaches your eye faster. Traveling through the water, it's moving slower, so it takes slower to reach your eye. So the visual effect is the look of a bent spoon because the light is hitting your eye at two different times. Another one might be the example of the fish in water. So if any of you have ever tried spearfishing before, or even if any of you have seen minnows swimming around your feet before, oftentimes when you look at a fish in water, it might appear here. You might reach out to actually grab the fish, but the fish is actually not only a different depth, but it's actually in a different location. So it's the same idea where light is traveling through water first, slower, and then as soon as light travels through the air, it bends because it's traveling faster. So the actual path of the light is here, then here. Again, your eye doesn't know this, so your eye is going to think that the light that's hitting its eye is actually coming from this direction. So we get kind of that apparent image. So just like in mirrors, when we were looking at those virtual images, those apparent images, it's the same thing with refraction. Your eye thinks the light is coming from over here, when in all reality, the water is actually bending the light. So what causes refraction? Refraction is actually due to the changes in the speed of light. So for example, light moves from air to water, the speed decreases. Different materials slow down the light by different amounts. So let's review this again. As light moves from air into water, the speed's going to decrease. So light is able to travel faster in air, and light is going to travel slower in water. We're going to be looking at different media. The term media just means materials. Different media are going to slow light down by different amounts. So water slows light down quite a bit, but other media might slow light down even more. The more light is slowed down, the more light is refracted. Remember, refracted just kind of means bent. So the more light is slowed down as it goes from one substance to another substance, the more light is actually going to slow down, the more it's actually going to bend. Let's talk a little bit about the speed of light. So the speed of light is essentially the fastest as that we know light can travel. Light travels around 300 million meters per second. That's really fast. So just to give you a perspective of how fast it is, that's fast enough to travel around the Earth 7 times in 1 second. So just like you can't run or walk as fast in a crowded hallway, light particles do not always reach their top speed. So this speed of light is actually light traveling through a vacuum. A vacuum means that there's no other particles, so that light is going to be able to travel at its top speed. As soon as you start introducing particles, it's likely that light is going to hit those particles, and that light is going to slow down. It's not going to be traveling at its top speed. So essentially, the more particles that you introduce, the thicker that a media is, the more likely it is to slow light down. Just a reminder that light is on the electromagnetic spectrum. That means it's transmitted in waves. So the particles in a medium slow down the passage of those waves. So again, we have those waves being transmitted. And as we go from one medium to a next, you're actually going to see these waves are actually going to slow down their passage and they're going to travel at a slower speed. So, for example, the medium glass. Glass is actually more dense than air, so light is going to travel slower in glass than it is in air. So you have this light traveling faster in air. As soon as it hits glass, it's going to slow down. There's more particles in the way, it's more dense, so you're going to see the slowing down of that wave. Let's talk a little bit then about what we call the index of refraction. The index of refraction is the amount by which a transparent medium decreases the speed of light. It's indicated by a number called the index of refraction. So essentially, the index of refraction is an actual number that we can associate with how much light is slowing down. So before we were just saying as light slows down, it's going to bend. Now using the index of refraction, we're able to say exactly how much light is going to slow down as it goes from one medium to another medium. The larger the refractive index, the more the medium decreases the speed of light. So if the index of refraction is higher, it means that it's going to slow light down more and more and more. I mentioned this before, but we're going to put it in writing now. Light travels the fastest in a vacuum. The refractive index of light in a vacuum is assigned the number of 1. So we know that light can travel at its top speed, that 300 million meters per second in a vacuum when there's no particles in the way. So the fastest that light can go, we give it the value of 1. This value is also actually used for air. So we don't really have a lot of vacuums here on Earth. So we go ahead and we say that light traveling through air is so close to how fast it goes in a vacuum, we just call it the same thing. So it's actually not exactly the same thing. It's 1.0003, but when we round, that's really not going to make much of a difference. So for this class, we're going to go ahead and we're going to say light traveling through air is actually going at the speed of light. So we know that since this is essentially the fastest you can go, 1, the index of refraction is the fastest you can travel. Anything above 1 is going to indicate that it's slowing light down. So for example, if we take a look, we have 3 different indexes of refraction here. We can see that water is going to slow light down. It's got an index of refraction higher than 1. Even more of an effect than water is going to be alcohol because it's got an even higher number. And the greatest effect here is going to be a diamond. It's got the highest number. So remember, as light slows down, it bends. So we would expect that light traveling through water is going to bend. And we would expect that light traveling through alcohol is going to bend even more. And we would expect that light traveling through a diamond is actually going to bend the most in this example. The refraction index of a medium, we actually give it a letter. So remember, physics does have some numbers involved. The letter that we're going to call it is N. So the refractive index in a medium is going to be called N. So all of these numbers we would represent with the letter N. It's determined by comparing the speed of light in a medium with the speed of light in a vacuum. This is going to lead to the following equation. And this is going to be what we're going to use to calculate our index of refraction. So remember, our index of refraction, that's that number that's somewhere above 1, is represented by N. The speed of light in a vacuum, that's also the same as the speed of light in air for the purpose of this class. So that's going to be 300 million meters per second. And then we're also going to divide that speed of light in the vacuum by the speed of light in the actual medium. So this is going to be how fast light is actually traveling in water, how fast light is traveling in maybe alcohol, or how fast light is traveling in that diamond. So our example here, our sample formula that we're going to have is N, the index of refraction, is equal to C, the speed of light, divided by V, the speed of light in a medium. So here we're going to take a look at a quick question that I might ask you around the speed of refraction. So I just wrote it out really quickly here. It says that light travels through jello at a speed of 2.46 times 10 to the 7 meters per second. What is n? So you're often going to see really big numbers here. You're going to see really big numbers because, again, we're talking in the millions. So first up, we have to figure out what information we've been given. We've been given, let's change colors. Let's go blue. We've been given the information of the speed of light going through jello. So remember, the speed of light in a medium is represented by the letter V. So we're going to go ahead and we're going to write V equals, and we know V is equal to 2.46 times 10 to the 7 meters per second. Now, at first glance, it doesn't look like you've been given enough information, but I want to go ahead and I want to remind you that we actually always know what C is, and C is that speed of light traveling through air or traveling through a vacuum. It's always going to be the same number. It's always going to be 3.0 times 10 to the 8 meters per second. So once we have the two values, here we can actually really easily see what we're solving for. So in this case, we have V, we have C, we must be solving for N. If we weren't sure, the question actually asks us, what is N? Remember, N is the index of refraction. So this question is asking us, what is the index of refraction of jello? So N is going to be equal to C. Well, remember, C is 3.0 times 10 to the 8 meters per second. And in this case, V is actually 2.46 times 10 to the 7 meters per second. Now, if you have trouble remembering this formula, I just want to remind you that C, the speed of light in the vacuum, is actually the fastest that light can travel. So your biggest number, 3.0 times 10 to the 8, is always going to go on the top. Your other number, your smaller number, is always going to go in the bottom. That means your answer is always going to be greater than 1. We like to include the units in physics to make sure they cancel out. So since we're dividing by the same unit, they're going to cancel out. And if you go ahead and you punch this into your calculator, you are going to get the number of 12.19 5, 1, 2, a bunch of decimals. Here in this case, we want to round based off of how many decimals we've been given. We were given something that had 2 decimals, so we want to keep 2 decimal points. So we're going to go ahead and we're going to round our value. Instead of calling it 12.195, that 9 is actually going to round up, and our answer is going to be 12.20. Now for the index of refraction, since our units canceled out, we actually don't have any units. So the index of refraction just looks like this. No units. The index of refraction of jello would be 12.2. Now we're going to take a look at another question that we could ask you. And this question here is asking, what is the speed of light in water? So again, it doesn't look like we have enough information, but I'm going to remind you, if we scroll up here, we were actually given the index of refraction of water, and that index of refraction of water is 1.33. So in this case, we actually know what N is for water. N is equal to 1.33. And remember, we always know what the speed of light is in air or traveling through a vacuum. That's that C value. That's always going to be the same number. That's always going to be 3.0 times 10 to the 8 meters per second. So once we lay out what we've actually been given, that's always the first thing that you want to do in physics, we can really easily see what the question is asking us for. So in this case, we were given N, we were given C, so we know automatically we're looking for V in this case. So that means we're going to have to rearrange this formula to tell us what the formula is going to be for V. This can actually be written in a triangle form as well too, for those of you that like triangles. I'm sure you remember them from grade 9 physics. So if we were going to write this out in a triangle, we would have, actually, let's do this a little bit bigger so you can see it better. It's a pretty small triangle there. Okay, let's try this again. Let's give you a bigger triangle. There we go, that's better. So in this triangle, we would have C on top, we would have V here, and we would have N in the corner. Remember that this line here means I'm multiplying, and this line here means I'm dividing. So in this case, I'm looking for V. V's over here. So V is going to be equal to C divided by N. We know it's C divided by N because we have C on top of N, and that on top of line means divide. So in this case, V is going to be equal to C. Well, we actually know what C is. C is 3.0 times 10 to the 8 meters per second. And we know what N is, that bottom number, that's 1.33. So all we have to do is we have to take 3.0 times 10 to the 8 and divide it by 1.33 in your calculator. Once you do that, you're going to get a really large number in the millions. That's exactly what we expect. So what you want to do is you actually want to put it in scientific notation. So scientific notation is you want to write the first number, which in your calculator should be a 2. And you want to write the second number. Remember, we are keeping 2 decimal places because we have 2 decimal places that was given to us. So we want to write one more number, and so that would be a 6. Right on your calculator, it should say 2.255. That would round this to a 6. For scientific notation, what you want to do is you want to put a decimal between the first number and the second number. We're then going to multiply it times 10, and to figure out what exponent we need for that 10, we need to count how many times you actually moved the decimal. So if you take a look at the decimal and you figure out how many times you moved it to the left, it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9. So you should actually see that you had to move the decimal 1, 2, 3, 4, 5, 6, 7, 8, 9 different times. So this here would be to the power of 9. In this case, we actually have our meters per second. Sorry, before we get too far, I knew that couldn't be right. Double check in your calculator. You actually only moved your decimal 8 times, right? Couldn't have 9. I can't count today, that's okay. I had to double check my numbers myself. So if you punch this into your calculator, right, you're going to get 2.22556. We're going to round that to 2.26. And you have to figure out how many decimal points away your decimal is. And you should have had to move your decimal 8 different times. In this case, if you take a look, you didn't cancel your units out. So since this is dealing with a speed, we are going to have units here. We're going to have it as meters per second. So we do have a couple other practice questions that are on D2L. I recommend you doing the practice questions. And then at the very bottom, you can actually just highlight and it'll show you the full solution for those practice questions as well too. So these are calculations I could ask you. So make sure you try those practice questions. Check the answers to your practice questions. And if you're still struggling, send me an email and we'll get you a little bit more help. All right, now that we know what refraction is, we can actually go and apply fraction. So in our next lesson, we're going to take a look at lenses.